Hello everyone, welcome back to our YouTube channel. In today's video, we will dive into the fundamental aspects of Python's built-in data types and numeric types. Understanding data types is crucial for any Python programmer as it forms the foundation of how information is stored and manipulated in the language. We will explore concepts such as getting the data type of variables, setting specific data types, and performing mixed arithmetic operations, and the essential skill of type conversion or Python casting. By the end of this video, you will have a solid grasp of these concepts, and we will even test your knowledge with some exciting exercises. So, let's dive into the world of Python data types and numeric types. Okay, so Python provides some built-in data types such as strings, dictionaries, list, set, frozen set, tuple, binary data types, and boolean data types. In addition, Python also provides a variety of specialized data types such as dates, times, fixed type arrays, heap queues, double-ended queues, and enumerations. In Python, variables can store data of different data types, and different types can do different things. We will discuss about each data type in separate videos. Now let's discuss about the topic how to get the data type of a variable in Python. In this explanation, we will explore how to get the data type of an object in Python using the type function and how it can help you identify the data type of variables in your code. Whether you are a beginner or an experienced developer, understanding the type function will undoubtedly prove beneficial in your program journey. So you can get the data type of any object by using the type function. In Python, the type function is built-in function used to determine the type of given object. It is a versatile function that helps you to find out the class or data type of variable or value in your code. The basic syntax of the type function is as follows. Here, object is the argument you want to examine. It can be any Python object such as variables, data structures, functions, or even classes. Let's look at some examples to understand how the type function works. Okay, let's begin by looking at some basic data types Python and how we can use the type function to identify them. So take a look at this at some basic data types we have in Python. So I'm creating a variable called num and assigning a value to it, and I want to know the data type of this variable. So I'm using type function to get the data type of this object called num, and now run the file and see the output. We got the result as int. So the data we stored in this variable, it is a type of data type called integer. Let's look at another example. I'm creating a variable called name and assigning a value to it, and I want to know the data type of this name variable. Using same type function we can get it name. Now let's run the file, see the output. We got string. So the data stored in this variable is type called string. And let's see another example. I'm creating a variable called eStudent and assigning a value to it, and I want to know what kind of object eStudent is using type function. And run the file, see the output. we got the output as bool. Bool means boolean. So in this example we have three variables called name and student. By applying the type function to each of them, we can see that num is an integer, name is a string data type, and student is a boolean. So the type function helps us easily identify the data types of these variables. Now let's move on to more complex data types. We will examine lists, tuples and dictionaries using the type function. Okay, see about complex data types. So I'm creating a variable called mylist and storing some values into the list 1 2 3, and I want to know the kind of that object the above my list is. What kind of object I want to know using the same function type, and run the file, see the output. So we got the result as list. So list is one of the data type available in Python. And let's see another example. I'm creating a variable called mytuple and assigning values to it 4 5 6, and I want to know the data type of this mytuple variable using type function, and run the file and see the output. We got result as tuple. So this is another kind of data type available in Python. And I want to know, I'm creating another variable called myDict, and I'm assigning some values to it. Let's say a 2, and I want to know the type of object the dictionary is using the same function print type my dictionary. So let's run and see the output, and we got the output as dictionary. So in this example we have three different data structures. One is my list, another one is my tuple, another one is my dictionary. So when we apply the type function, each of them we can see that my list is a list, my tuple is a tuple, and my dict is a dictionary. So the type of function here gives us the, and it gives us the option to know about the what kind of object we are using. Similarly, we can use the type function to determine the types of functions and classes. Let's look at this example also. Okay, let's look at how to get the functions and classes type using type function, functions and classes. And here I'm defining a function called my function, and I'm returning a value called hello world, and I want to know the type of function, what kind of type of function it is, using the same type function we used, my function. And let's run this file and see the output. So we got the result as string. So we find that the type of my function is a type of string. Let's look at another example. I am creating a class called my class, and I want to know the type of this class using the type function. my class. Run the script and see the output. So we got type as type. So in this code we define a function called my function and class called my class. Applying the type function on both, we find that my function is a type of string and my class is a type of type. So we will have a separate section on functions as well as classes. For now, please focus on how to get the data type of different objects. It's important to know that the type function returns a type of object which represents the type of the given object. So you can compare this type object with other type objects to perform type checking in your code, or use it in various control structures based on the data type. Additionally, for type checking, Python provides isInstance function, which allows you to check whether an object is an instance of a particular class or type. So this is often more appropriate for type checking in Python code than directly using type function. So we will explain about this isInstance function in different session when we explain about classes. So that's wrap up this discussion on the type function in Python. If you have any questions or need further clarification on this topic, please do not hesitate to leave a comment. Let's jump into another topic about setting the data type. In Python, you can set specific data types to variables using constructor functions. So constructor functions are essential for creating objects of a particular data type in Python. So here constructor function are built-in functions that allow you to create objects of specific data type. By using these constructor functions, you can convert values to a particular data type. So let's explore how this works through some examples. Okay, let's start with string constructor function. So this string constructor function allows us to create a string object with a specific value. For example, here I am creating a variable called x and I am using string constructor to assign a value to it. I am assigning a value called hello world. So in this example, we are using string constructor function to create an object with the value hello world. So the string constructor is used to convert values to a string data type. Even though hello world is already a string literal, but here using string constructor explicitly converts it to a string, which is generally not necessary in this specific case. Okay, just I want to know that what type of object the x is using the type function here. Let's see what we will get. So the x is an object of string type. So now let's look at another example. We have int constructor. Similarly in Python, it allows us to create an integer object with a specific value. Let's see an example. I am creating a variable called y and I am assigning a value to it using int constructor. I am not assigning directly integer value to y. I am using a constructor to assign a value to y variable, that is int constructor. And let's see what will be the output to know the data type of this y variable. Now run the file. We got integer. In this example also we are using int constructor to create an integer object with the type of the value 20. The int constructor here used to convert values to an integer data type. So in this case the number 20 is already an integer value, but explicitly we are using int constructor. So it can be useful when you have a different data type to convert this value to an integer. You will see how we can convert it into with further examples. So now let's explore the list constructor function, which enables us to create a list object with specific elements. So list constructor. So we have in Python. Let's see, I am creating a variable called fruits, and I am assigning some values. I want to assign some values to it using list constructor. So here I am building a list variable, data type of list. Let's assign some values to it. Apple, grapes, cherry. So we have three values we have assigned, and we used list constructor to create an object. Let's find out what kind of data is stored in this fruits variable using the type function. If you run this script, we will get the type as list. So here we using list constructor function to create a list object. So this object is type of list. So we created a list object with the elements of apple, banana, grapes, cherry. So the list constructor is used to convert these literal objects to a list data type. Similarly, we have tuples, sets, constructors to create using constructors to create a variables. So normally when we creating a list constructor, with a list of elements, we use square brackets. When we want to create a list object, for example, I am creating fruits and I'm assigning some values to it called banana and orange. So this is how normally we create a list object without using list constructor. This is how we create. Whenever you want to create an object without a constructor, this is how we use square brackets. But in this scenario, we used a list constructor to create an object with a kind of list. So you can create like this also. Whenever you want to create a list without constructor, you can create like this using square brackets, or you can use list constructor. In conclusion, setting specific data types in Python can be achieved using these kind of constructor functions. These constructor functions allows you to convert values to their respective data types explicitly. So while it is sometimes necessary to use these constructions, Python's dynamic typing system generally handles data type inversion automatically. So before we go, we have a special treat for you. We have prepared a PDF file with some exercise on each data type we covered today. So this exercise will help you reinforce your understanding. So make sure to check it out in the description below and challenge yourself with some coding fun. So if you found it helpful, don't forget to give a thumbs up and subscribe to our channel for more exciting Python content. If you have any questions or suggestions, please leave them in the comment section. So let's dive right into the fascinating world of Python numerical types. In our previous video, we already covered about the string data type And now it's time to explore yet another essential data type, that is numeric data type. Okay, let's explore one of the fundamental concepts in Python programming, that is numeric types. Specifically, we will focus on integers, floating point numbers, and complex numbers. We will go through each type and understand how they work and see some interesting examples. So let's dive right in. Numeric types are fundamental data types used in programming to represent numerical values. So Python, like many other programming languages, supports various numeric types. So in Python we have three distinct numeric types: integers, floating point numbers, and complex numbers. So let's dive into each type with examples. Alright, let's see some examples about integers in Python. So when we talk about integers are whole numbers without a fractional component. So they can be positive, negative, or zero. So in Python, integers have unlimited precision, meaning they can represent a very large or very small numbers accurately. So you can declare an integer in Python simply by assigning a numerical value to a variable. So let's see some examples. I have created a variable called a and assigned a number 42, and variable b and assigned a negative value -12 and c 0. So here we created three variables and assigned three different kind of integer values, such as 42, a positive integer, this is a positive integer, and a negative integer, this is 0. So three types of integers we assigned, and these integers have unlimited precision, which means we can accurately represent extremely large or very small numbers without any loss of precision. Unlike some other programming languages that they have fixed integer types, for example int 32, int 64. So but in Pythons we don't have such type of fixed size integer types. In Python, integer types automatically adjust its size to accommodate the magnitude of the number being represented. So this unlimited precision is achieved by dynamically allocating some memory as needed to store the integer value. So as the number grows larger, Python allocates more memory to accommodate the additional digits. So this allows Python to represent integers of virtual any size and limited only by the available memory of the computer running the program. So let's look at some examples to understand how Python handles integers with unlimited precision. So we will see examples about large positive integers, negative large integers, and some very small positive integers, and how Python can handle this. Let's see one example about large positive integer. So we will create a variable called large integer and we will assign some value to it. So this is a large positive integer number we are assigning to a variable. I want to print the output of this large integer in the run window. See what we will get. Let's run the file. So here we got the result same as it is we assigned to this variable. So there is no loss of data in Python. So Python can represent a large positive integers with precision, ensuring that no data is lost due to the size of the numbers. Let's see another example about assigning a negative integer value, a large negative integer value like minus some number. So this is a large negative number and we are assigning it to negative. integer variable. So this is how we can assign a large negative integers in Python. Let's see the output of this variable negative integer and run the file, see the output. So we got the output without any loss of data. This is how Python handles large integers without loss of data. So Python can also accurately represent very small positive integers using scientific notation. So where the exponent indicates the number of decimal places the actual value has shifted. Let's see some example about small positive integer. We'll create a variable called very small integer equal to, we'll assign some value like 0.00001. So this is a very small integer value we assign to this particular small integer variable. Let's see the output, what we'll get, and run the file. So we got an integer, a small integer value with a scientific notation. So this is how we can assign a large and small and some different positive and negative integer values in Python. It's important to note that although Python can accurately represent these large and small integers, performing arithmetic operations on extremely large integers may take more time compared to regular sized integer values. So this is due to increased memory usage and the additional calculation involved. So however, the advantage of having unlimited precision outweighs this limitation when dealing with critical tasks that requires precision representation of large numbers such as cryptography, number theory, and other mathematical applications. So that's all about integers in Python. Let's have a look at another type called floating point numbers. Alright, let's see some examples about floating point numbers in Python. So before going, let's see what these floating point numbers and how we can deal with this. So generally floating point numbers are numbers with fractional component. So the integers are without fractional component. When it comes to floating point numbers, these are represented with a fractional component. So they can represent both whole numbers and decimal values also. So Python, to represent floating point numbers in Python, it uses a double precision to implement floating point numbers. So which means they are typically represented using a double data type. So which is generally a data type from the C programming language. So Python uses this double data type method from the C programming language. So double precision is widely used formatting method for representing floating point numbers, and it is the default choice for most of the programming language including Python also. So typically represented using float data type. However, the actual precision and the internal representation can vary depending on the machine types. So let's look at some examples of floating point numbers and how exactly they display. So I'm creating a variable and assign a value 3.12, and another variable called y, and assign some negative value 0.24, and z equal to 2.4. So here we created three variables using floating point numbers. So this is how we represent floating point numbers in Python. So the fractional component, here we have fractional component when representing floating point numbers. So it's representing the whole numbers plus and decimal values also. So just for your information, we have explained in detail with some examples about double precision topic. I mean about this double data type and double precision in the PDF, and we have it in the description. You can have a look at it if you want to know more about this, but for now it is not recommended by us. Also, you can find the explanation completely if you also look at it, just for your information. Let's see some examples about complex numbers. All right, let's discuss about complex numbers. We'll see what are the complex numbers in numeric data type. So complex numbers. So complex numbers are numbers with both real part and imaginary part. So they are usually written in the form of a plus b j. So the complex numbers are generally written in this form, a plus bj. Here a is an imaginary part, sorry, a is a real part and b is imaginary part, and the j here represents a square root of -1. So this is how Python we can represent complex numbers in Python. So Python supports complex numbers using complex data type. So let's see some examples of complex numbers in Python. So we have a variable called p and we are assigning some value which is a complex number. So here we are representing complex number in the form of a plus bj. So here 2 is a real part and 3 is imaginary part. Similarly, we will see another example, q equal to minus 1j. So this is another complex number. Here we have only the imaginary number, imaginary representation, and r equal to 4 plus 0j. So this is another example of complex number. Here the real number 4 represented as complex number, 4 represented as complex number. So this is how we represent complex numbers in Python. Okay, I know it is a bit complex topic to understand about complex numbers if you really hate mathematics, but I will explain in another way with some more examples how exactly complex numbers works in Python. So complex numbers are mathematical concept generally that extends the idea of real numbers by introducing an imaginary part. So as we discussed, a complex number is represented as a plus bj. A plus bj, they generally represent in this format, but where a is real part and b is the imaginary part and j represents square root of -1. So also here j denotes as I in some mathematical literature. So the imaginary unit j makes complex numbers different from real numbers. So allowing in Python, complex numbers are natively supported using complex data type. So let's dive into details with some more examples to understand this complex numbers topic. Let's see some basic complex number. For example, basic complex number. We created a variable and we assign some value 2 plus 3j. So in this, let's try to print the output, see what we will get. Let's print the variable basic complex and see the output. So we got 2 plus 3j. So in this example, so basic complex variable is a complex number, so with a real part of 2 and imaginary part of 3. And we'll see another example about a pure imaginary number. A pure imaginary number example. So create a variable called pure imaginary and let's assign some value to it. It is 0 plus 5j. So here this value, this is a pure imaginary number, complex type. Let's see the output. If we print this pure imaginary number, what we will get? Only 5j. So if you observe the difference between basic complex number and pure imaginary number, here it is representing a real value plus imaginary value. So this is a real complex number. When it comes to pure imaginary, we have zero value, and here it is representing only imaginary part. So we consider it as a pure imaginary and see the output what we got, only 5j. So this is how complex numbers works. So complex numbers also supports some standard arithmetic operations just like real numbers. Python handles complex numbers arithmetic in a way that preserves both imaginary and real parts. So let's see some arithmetic operations using complex numbers. Let's perform some additions using complex numbers. Let's say I have a equal to 2 plus 3j and another variable b equal to -1 and -2j. This is another complex number and I want to perform addition. So c is equal to a plus b. So let's see what will be the output. I want to display the result of c in the output screen. We will run and see the output. We got 1 plus 1j. So this is how we can perform arithmetic operations and complex numbers. And if you want, we will see another example of subtraction. So similarly, in the above example, we can create d variable and we can use this above c minus a. Sorry, yeah, we are going to create a variable called t and equal to a minus b. So this is one variable and I want to see the result of d. I created a variable called dA. So we have a space. How it works. So I want to see the result of dA. Let's run this, see the output. So we got plus 3 plus 5j. Subtraction. Similarly, we can perform multiplication and division also on complex numbers. So complex numbers find applications in various fields including physics, engineering, signal processing and electrical circuits. They are specifically useful for representing quantities with phase and magnitude, such as in AC circuits or the study of wave oscillations. So in Python, complex numbers can be used in mathematical calculations, scientific simulations and other tasks that involve complex mathematical relationships. So it's important to note that some mathematical operations like calculating the square root of negative number naturally lead to complex results. So Python can handle these computations efficiently using its built-in complex support. So that's all guys. Hope you understand the complex type in Python. If you have any questions, feel free to ask in the comment section. We would be happy to address all your questions. So let's jump into another topic, that is type conversion. But before jumping, I would like to explain a small topic about arithmetic operations using numbers. Let's see. Alright, so Python fully supports mixed arithmetic operations. So mixed arithmetic operations. So which means we can perform mathematical operations like addition, subtraction, multiplication between different numeric data types. So Python has several numeric data types. We already discussed about that, such as integers, floating point numbers, and complex numbers. So while performing arithmetic operations in Python, we have one technique called widening of operands. So Python generally uses this technique whenever we perform arithmetic operations on numeric types. So when you use a binary arithmetic operator like addition, subtraction, multiplication, and division, so when you use these kind of binary arithmetic operators with operand of different numeric types, so Python handles the situation by converting one of the operands to a wider type to avoid data loss. Let's see how exactly this works. So we have two variables, x is equal to 5 and y is equal to 2.5. So we have two variables here, and if the operands have two different types, so here we have one operand, this is the operand and this is the operator. This is not arithmetic, this is an assignment operator, but we will see what is when we perform arithmetic operation. So this is an integer type, we already know, and this is float type. So we have two different types of operands here. So when we have a situation like this, so Python handles this situation by converting one of the operand to a wider type. So it converts one of the operand, one of the value to a wider type to avoid data loss. So the order of this widening technique from narrowest to widest, that means integer is the narrowest value, then floating point numbers, and floating point numbers are narrowest than complex numbers. So this is the order of widening operands. So using this order, the Python handles different kind of operands when we perform arithmetic operations. So let's see example about addition of an integer and a floating point number. So we have two variables already. We perform some arithmetic operation on this. So I want to perform arithmetic operation x plus y. We have, so let's see what will be the result when we execute this. I want to see the result of x plus y in the output screen. Result. Let's run this file, see the output. So we got 7.5. So in this example, Python converted integer value. This is the narrowest value, and this converts the integer value to a floating point to a wider type. So this is the wider one, this is the narrowest value. So it converted to a wider type. So when we performed addition task, so the result is 7.5. So this is how the Python handles different kind of when we perform arithmetic operations between different kind of operations. So let's see another example about multiplication. We have a variable called a, and we assign a value to it 3.0, and we have another variable b, and we assign some complex number 2 plus 3j. So here we have two variables with the two different kind of operands. One is floating number, another one is complex number. Let's perform some multiplication and see the output. So I'm performing a into b. So let's see what we will get in the result. Print and run the file, see the output. We got 6 plus 9j. Here the floating point number the Python converted this narrowest value to a complex type. So based on the widening technique, it converted the narrowest value to a widest number. As a result, we got a complex number. So a complex number with a zero imaginary part. So here we have 0. So and then performs multiplication on these two values. The result will be complex number. This is how the Python handles arithmetic operations using widening of operations. Hope you understand about this topic. So if you have any doubts or any questions, please do not hesitate to comment in the section. So let's jump into another interesting topic, that is type conversion. So in Python, type conversion also known as type casting. So we will discuss about this topic today, also known as type casting. So this type conversion is the process of converting one data type into another data type in Python. So we all know generally Python is a dynamically typable language, meaning the data type of a variable is determined at runtime. So no need to declare the data type whenever you create a variable. So sometimes you may need to change the data type of variable to perform certain operations or to meet specific requirements in your program. So Python provides some inbuilt functions to perform this type conversion activity. So here are some common types of conversions you might encounter in your programming experience. Let's try to see what are those. So you want to convert an integer data type to a float. So let's see how you can perform an integer to a float conversion. So I have a number data type of integer, that is a value 10, and another one number data type of float, and I have a value. So here I have integer value and I want to convert this integer value to a floating point number, and we can do that using float function. This is float function we have. This is an inbuilt function in Python we have, and it facilitates us to convert an integer, any other numeric data type, to a float. Let's see how we can do it. So here I am mentioning the variable name of integer value, and I want to see the result. Print m float and run this file, see the output. Sorry, yeah. Current file, yeah. Now we got a floating point number. Here we have variable, we stored integer value in the variable numInt, and we converted this integer value to floating point number using float function. The result is floating point number. So if you want to know the type, we can print type here and see the kind of data type is stored in this variable numInt. If you run, we will get floating point number. Sorry, we should use this variable float. Now we will get floating point number float. So this integer value is converted into floating point number, and it is stored in a variable called numFloat. So the type of value stored in the numFloat variable is floating data type. This is how you can convert a integer value to a floating point number using float function. Similarly, we can do vice versa, I mean floating point number to integer. So we'll see one example. So I have a number called m float variable and assign 3.14. So I want to convert this number float to integer value. How we can do that? So I have a variable integer. Let's see how we can do this. We can do this using int function. So this is another inbuilt function. Using this function we can convert the float point to integer value. Similarly, like we did in the above example, we can do the same thing here. So num float and see the output. So 3, Python converted 3.14, this floating point number, to an integer using int function. So this is how you can convert a different data type into another data type using inbuilt functions. Similarly, we can also convert a string to an integer or a float value. We will see how we can perform. So I have a number variable and assign value 25. So this is a number. When we declare this number between two double quotes, it becomes integer. So strings. So the strings must be specified between two single quotes or double quotes whenever you want to assign a string variable to a variable. So this is a string variable, but I want to convert this string variable to numbered integer value. So I have another variable. I want to convert this string to integer. We can use the same integer function here, int function, to convert a string to an integer. Let's see what will be the output. And I want to see the result. Print. Let's give another different name and try the result. We got 25. So here Python converted string value to integer value. Let's see the type of this one once, whether it is a string or integer type. If you run this script, it gives us the integer. So initially it was in string data type, but we used the integer function, int function, to convert the string into integer. This is how we can convert strings into a numerical values. So however, make sure the string contains a valid number, otherwise you will encounter a value error. See, I have alpha numerical value, but I'm trying to convert this alpha numerical value to an integer, but this is not a valid number. If you try to execute this, you will get an error. See what will be the error. We got value error, invalid literal for integer with the base 10. So if you see here, we given an invalid value. Whenever you want to try to convert a string to an integer, you should give a valid number in the string variable. This is how you convert different numbers to different kinds. So this is how type conversion works. So you can also convert lists, tuples, or set to a string using string function. Let's see one example how you can convert other data types also. We will see one example. So here I have a variable called mylist, and I'm storing some values like 1, 2, and 3. So I want to convert this list data type. This is a type of, let's just see what is the type of this data type. My list. So this is a comment out this and run print type of my list. So this is the data type of list. So I want to convert this list to a string value. So just I want to see the string value. So we can do that using a string function. This is another inbuilt function. We can convert lists or tuples or sets using to string value using this string function. Let's see. I want to convert into a string function this list data type and see the output. Print and so it is converted into string and see the type whether it is converted into string or not. Type of list. So earlier the list is in list data type. Now we converted this list data type into string data type and we stored that data in list string variable and the type is string. So this is how you perform conversion, type conversion in Python. So there are some of the common type conversion scenarios in Python. So we can perform on different data types. So remember that not all conversions are possible, especially between incompatible data types, like I explained with string data type. So always ensure that the conversion is appropriate for your use case and handle potential errors that may arise during the conversion process. So you cannot convert complex numbers into another data type. Remember this. You cannot convert complex numbers into another data type. So there may be times when you want to specify type of variable. This can be done with casting. We will see what is this casting now. Typecasting. So casting in Python is therefore generally done using constructor functions. I said string function and integer function and float function. We can call it as also constructor functions. So let's see how exactly this casting works in Python. Let's say I want to create a variable called x and I want to assign an integer value to this x value. Directly assigning one value to it considered as an integer value, but I am assigning a value to x variable using a constructor function, that is int constructor function. So now I am assigning a value called 10 to x variable. So this is now this x variable storing a value of 10 of integer data type. Similarly, I have y equal to and float of 2.0. This is another example. And similarly, if you want to assign y equal to some string of 3.0. So this 3.0 is not any numerical data type. This is a string data type because we used a string constructor to assign a value to y variable. So using these constructor functions or this int, float or string functions, we can cast whenever you want to. This is a casting procedure in numeric data types. This is how we can perform typecasting or type conversion. This typecasting and type conversion both are similar. Here we are converting and here we are assigning the value using the same functions. So we hope you found this helpful, and if you have any questions or any queries, please do not hesitate to post in the comment section. So that's all about numerical data types. We hope you found this entire Python programming video on built-in data types and numeric types, informative and engaging. So remember, mastering data types is a fundamental step in your journey as a Python programmer. Whether you are dealing with numbers, strings, or more complex data structures, understanding these complex concepts will make you more efficient and robust. So practice and experimentation are key to truly internalizing these topics. So keep coding and exploring. If you have enjoyed this video, do not forget to give it a thumbs up and subscribe to our channel for more exciting Python tutorials. Thank you for joining us and happy coding.